Okay, so this follows on from what I was saying towards the end of the last lesson. A function can only have an inverse if the function is what's known as a one-to-one function. Now, we've met the vertical line test before, so you couldn't have a single x value giving two y values and it be a function. This one here means that we can't have two different x values giving us the same y. And that leads us to something called a horizontal line test. And the rule is the same. If any horizontal line on the graph crosses at most once, the function is one-to-one. So as soon as you can find a horizontal line where it crosses more than once, then it's not one-to-one. And we call that a many-to-one function. So we've got sine x here again. It's always a great example because it goes off to infinity. There's actually an infinite number of crossings. And we've got 4 of them, or 5 of them actually, on our picture. So this one here is actually many-to-one. And that means, from what we're saying here, that we can't find an inverse of that. At least we can't find an inverse if the domain is allowed to be all real values. This down here is also sine x. I might as well do this one next. So draw any horizontal line on there. It's either going to cross once, or if it's up here, it's not going to cross at all. And not crossing at all is absolutely fine. Remember that it says at most once. So once or no times at all. So this one is one-to-one. And that means we can find an inverse. And this one here is actually sine x as well, but it's on a restricted domain. And we've talked about restricted domain a little bit before. The domain is restricted to be between negative pi by 2 and pi by 2. Straight lines are always one-to-one unless they are horizontal. If the line's horizontal, then it's clearly not one-to-one. And this one here, which is a quadratic graph, that clearly is not one-to-one. We can see 2 intercepts here and here. And so this one is a many-to-one function.